In this video, we're going to look at the different methods of purification and separation. And this chapter actually builds on the previous chapter, which is on element, compounds, and mixtures. In element, compounds, and mixtures, we learn that elements and compounds, they are actually pure substances, whereas mixtures are impure. We went on to learn that mixtures are made up of two or more substances that are not chemically combined. Right? Since they are not chemically combined, we can actually separate them easily using physical methods. So in this video, primarily we're going to look at the different physical methods that we can use to separate mixtures, and in the process we purify them. We separate them into the pure substances as shown in the diagram. Now, in order to remember the methods more easily, it will be good to classify them according to the types of mixtures. So we're going to look at three types of mixtures. First type would be a solid mixed with a liquid, so solid-liquid mixture, or we can have a solid-solid mixture, and lastly we look at liquid-liquid mixtures. So the first type of mixture that we're going to look at would be a solid-liquid mixture. So when you have a mixture of a solid and a liquid, in order to know which method to use, you need to ask yourself this question. Does the solid dissolve in the liquid? Meaning, is the solid soluble in the liquid? Or is the solid insoluble in the liquid? Okay. An example of a mixture where the solid is insoluble in the liquid would be sand plus water. Alright, and an example of a mixture where you have a solid which is soluble in the liquid would be salt plus water. So when you have a solid that's insoluble in a liquid, there's actually only one way to separate them, which is filtration. And then if your solid dissolves in the liquid, then you need to further ask yourself, do you want to collect the solid or do you want to collect the liquid? If you want to collect the liquid, then we have to use a technique called simple distillation. If you want to collect the solid, there are two different methods for available. One of them is known as evaporation to dryness, and the other one is known as crystallization. Now, it's important for you to first know which method to use in what situation before we go on to look at these techniques in detail. So for now, some of these techniques may sound foreign to you. It's okay. Just try to remember which technique to use in what situation. Alright, in the next part of the lesson, then we'll look at the techniques in detail, meaning the experimental setup and the principles behind it. So this is a summary of what we have seen. In a solid-liquid mixture, in order to know which method to use, you need to ask yourself whether the solid is soluble in the liquid or insoluble in the liquid. For solids that are insoluble in the liquid, we have to use filtration. For solids that are soluble in the liquid, we need to further ask ourselves whether we want to take back the liquid or we want to collect the solid. In the event where we want to collect the solid, there are two methods to use: evaporation to dryness and crystallization. In the event where we want to collect the liquid, then we have to perform a technique called simple distillation. Now, in the next part of the video, we're going to look at three techniques in greater detail. We're going to look at filtration, we're going to look at evaporation to dryness, and then crystallization. Now, how about simple distillation? Simple distillation, we'll look at it later on when we discuss liquid-liquid mixtures, because simple distillation is also used to separate liquid-liquid mixtures. So we're going to look at that technique in greater detail when we come to liquid-liquid mixtures. So as mentioned, filtration is to separate a solid-liquid mixture where the solid is insoluble in the liquid. The technique is very simple. All you need to do is to pour the mixture. So for example, if I have sand and sand and water, all I need to do is to pour the mixture into a setup as shown. So what do we have here? We have a filter funnel, and on the filter funnel we have a piece of filter paper. Okay, and then we have either a beaker or conical flask that's underneath the funnel. So when we pour the mixture through the filter funnel with the filter paper, what's going to happen is that your sand is going to be trapped by your filter paper, whereas your water is going to flow down your funnel into the beaker. Now, one thing to note is that the solid that is stuck on your filter paper is known as the residue, whereas the liquid that flows through, the water that flows through, is known as your filtrate. Okay, the next thing that we need to learn is how does filtration work. Okay, how does filtration work is that your filter paper actually contains many small holes called pores, and these small holes are just big enough for your water particles to pass through, or your liquid particles to pass through, but they are small enough to trap the very big pieces of solid particles. So this is your solid. Okay, so this is the principle behind the method of filtration. So the next method that we'll look at would be evaporation to dryness. This method is to separate a solid dissolved in a liquid, and we want to obtain the solid from the mixture. Okay, so for example, if we have a salt solution, salt plus water, if we want to get back the salt, what can we do is that we put the mixture into a evaporating dish. All right, this piece of apparatus is called an evaporating dish, and then we heat it strongly. So what happens is that your water, when it reaches around 100 degrees Celsius, your water is going to boil. All right, and the melting point of salt is very much higher than what we can achieve using the Bunsen burner. So after all your water has boiled off, the solid salt will remain in the evaporating dish. Alright, so using this method we can get back the solid by evaporating or by boiling away all the liquid. Now, as mentioned, there is another technique. This is one method for collecting the solid. There's another technique called evaporation, called crystallization. Alright, so why is there a need for a second technique? It's because not all solids can withstand the strong heating in order to boil away all the liquid. For example, if now I have a sugar solution, okay, I have sugar dissolved in water. If I have sugar solution and I heat it very strongly until all my water has boiled off, what happens is that your sugar will be burnt, okay, will decompose. All right, or in colloquial terms, it will chao da. All right, so we don't want that to happen. For solids that are not stable to heating, we need to use a more gentler technique known as crystallization. So in crystallization, the setup is almost the same. So let's say we have sugar solution now, sugar plus water. Now we heat it as well, but we don't heat it until it's completely dry, because that will cause your sugar to decompose. So we heat until the solution is saturated. Alright, so what does saturated mean? For that, we need to first review the definition of a solution. Now, imagine this scenario where I dissolve some salt into water. So I add some salt in water, Okay, and on adding and stirring, the salt dissolves to give me a colorless solution. Okay, so some of the terms that we need to take note is this: the solid that we dissolve in the liquid, the solid that dissolves is known as the solute, and the liquid that we use to dissolve the solid is called the solvent. Okay, when the solute dissolves in the solvent, the thing that we get is called a solution. Okay, so what exactly is a saturated solution? Now, imagine if I add some salt to water and I stir, the salt will disappear. Now, what happens if I add some more salt and I stir? It will continue to disappear. But imagine the scenario where I spam a lot of salt into the solution. There will come a point where the salt will not dissolve anymore. Alright, then we say that the solution is saturated. So what does it mean? It means that the solution already contains the maximum amount of solute that it can dissolve. Okay, so the solution already contains the maximum amount of solute that can be dissolved. Adding any more solid or adding any more solute after that, the solute would remain as a solid. It will not be dissolved anymore. Alright, so in the first step of crystallization, we need to heat the solution until it is saturated. Now, there are two things to take note here. How do we know that the solution is saturated? One way is to use a glass rod and dip it into the solution. And after removing the glass rod from the solution, if crystals form immediately on your glass rod, you see solid forming immediately on the glass rod, then the solution is saturated. Alright, if you dip the glass rod into the solution and on removing, you see liquid or solution on the glass rod, then the solution is not saturated yet. That's the first thing. Second thing, a common question that students will ask is, why would the solution become saturated when you heat it? Okay, now imagine, how do I get a saturated solution? One way is that I continue to add more and more solute into the solvent until the solvent cannot dissolve any more solute, then it's saturated. Alright, let's say I don't want to add more solid. I don't want to add more solute to the solution. How else can I make the solution saturated? The second method is by removing the solvent. Alright, so we remove the solvent by boiling it away. And with lesser and lesser solvent present, there will come a time where the solution, the remaining solvent, can hold just the amount of solute that's present. Then the solution becomes saturated. Okay, so the first step of crystallization is to heat until the solution becomes saturated. Then what happens after that? We leave the saturated solution to cool. And what happens when cooling is that your crystals will start to appear. Okay, so why would crystals appear when you allow a saturated solution to cool? Okay, for that you need to know another concept related to solubility. Now, solubility of a substance actually increases, is higher at a higher temperature compared to at a lower temperature. That is why when we dissolve our coffee powder, when we dissolve our Milo powder, we use boiling water or we use hot water, because we want more of it to dissolve. Alright, the hot solvent can dissolve the solid better. Okay, so solubility of a substance is higher at higher temperatures. So what happens when your solution cools down? Alright, when your solution cools down, the solubility of the substance decreases. Meaning it was saturated before. If the solubility decreases, now whatever solid that it cannot dissolve would then come out as crystals. Alright, an analogy is this: when you go to a buffet and you see all the spread of food, alright, suddenly you get very hungry. Your appetite is very much better. Alright, so you eat and eat and eat until your stomach cannot contain any more food. Alright, but then when you go back home, suddenly your appetite becomes smaller. Alright, what happens to the excess food that you have eaten? Then you will vomit out. You will vomit out in the form of crystals. Alright, so that's how crystallization actually works. So after getting the crystals, that's not the end of the story, because your crystals is now mixed together with the solution. So you need to perform a filtration first. Okay, you need to perform a filtration, and then what happens is that you will get your crystals as the residue. Okay, and that's not the end also, because if you want really pure crystals, right now your crystals contain some of the solution on it. So you need to wash the crystals with some deionized water. Deionized water meaning pure water. Okay, water with any ions in it removed. Okay, so we need to wash with a bit of deionized water, and then we need to further dry the crystals. Okay, how do we dry the crystals? We put it on a piece of filter paper, and then we use another piece of filter paper and tap it gently. Alright, so dry between pieces of filter paper. So that is the entire crystallization process. So before we move on, again, crystallization is used to recover solids that can dissolve in a liquid. But these solids are not stable to strong heating. Therefore, we cannot use evaporation to dryness. We need to use this this entire process known as crystallization. Now, also note that crystallization is actually similar to evaporation to dryness. Just that in evaporation to dryness, we heat until all the solvent has boiled off, all the solvent has evaporated. In crystallization, we heat until the solution is saturated, and then we stop. We don't heat it until it's completely dry. So the next kind of mixture that we're going to look at would be a solid-solid mixture. This is the second type of mixture. When you have a solid-solid mixture, you need to ask yourself this: SMS. Okay, SMS. So you need to ask yourself, is one of the solid soluble in water or in any solvent? Is one of the solid magnetic? Or does one of your solids sublime? At this point, some of you all may be wondering again, what is sublime? Okay, we have learned in kinetic particle theory that for some solids, when you heat the solid, it doesn't turn into a liquid, it turns into a gas directly. Alright, so we say that such solids, they sublime. Alright, and the process of turning a solid directly into a gas is known as sublimation. There are three solids in the syllabus that we need to know can sublime. So first would be solid carbon dioxide, or your dry ice. Number two, solid iodine. This is the one that is frequently tested in this chapter. And lastly is your solid ammonium chloride. Okay, so an example of a solid-solid mixture where one is soluble and the other one is not would be, for example, sand and salt. So in this case, since salt is soluble in water, we can actually separate them by, number one, adding water. Okay, after adding water, now we will have sand in a salt solution. So how do we separate the two is to perform a filtration. We need to filter, and then we will get the salt, then we will get the sand in the residue, and we'll get the salt solution in the filtrate. Alright, so next step, in order to get back our salt, we can do evaporation to dryness. Okay, evaporation to dryness, and when we evaporate or when we boil away all the water, the salt will be remaining in your evaporating dish. Next, an example of a solid-solid mixture where one of them is magnetic and the other one is not would be sand and iron. Okay, iron is the only metal in the syllabus that you need to know is magnetic. So this is very simple. If you have sand and iron, iron is magnetic. So all we need to do is to use a magnet. Okay, when we apply a magnet to the mixture, your iron is going to be attracted to the magnet, whereas your sand remains in the container. The last type of solid-solid mixture where one of them can sublime and the other one doesn't. The example would be sand and solid iodine. So solid iodine, we know that it can sublime. Alright, so how do we separate the two? Now imagine that we have a mixture of sand, alright, and iodine. We get sand and iodine. One of them can sublime, the other one cannot. So the way to separate them is to apply heat. What happens when you apply heat? Your iodine is going to sublime to form iodine vapor. Okay, if you can recall, iodine vapor is actually violet. Right, so we can actually see a purple gas appearing. Alright, but by simply heating, what is going to happen is that your iodine is going to just escape into the atmosphere, into air. Alright, and it's not collected. So if you want to collect the iodine, what do we need to do? This is a very elegant setup. All we need to do is to take a filter funnel, alright, a filter funnel, and then we invert it on the evaporating dish. Okay, on the filter funnel we put a piece of cotton wool to slow down the escape of the gas, and then once your iodine vapor touches the cold surface of your filter funnel, what happens is that it will form back your iodine solid. Okay, so the funnel actually provides a cold surface for your iodine vapor to form back the solid. Alright, so in this case, your iodine solid can be collected on the filter funnel after that. So this is a summary of the techniques available to separate solid-solid mixtures. And as mentioned, we need to check whether is one of the solid soluble, is one of the solid magnetic, or does one of the solid sublime, and then we apply the relevant methods. Type of mixture that we're going to look at will be liquid-liquid mixtures. And when to separate a mixture of liquid and a liquid, we first need to ask ourselves, do the two liquids mix well? Alright. For example, when you add oil and water, alright, if you add oil plus water, you will find that no matter how hard you shake, the two liquids do not mix well. We call them immiscible. Okay, so we will actually see two layers, oil and water. However, if you add, for example, ethanol is an alcohol. When you add ethanol and water and you shake, you find that there's only one layer. So ethanol and water, they actually mix very well. So we call them miscible. So to know which method to use for liquid-liquid mixtures, we first need to ask ourselves whether the liquids are miscible or immiscible. Now, if the liquids are immiscible, we can use something called a separating funnel. Okay, a separating funnel. If the liquids are miscible, then there are two methods that we can use. We can either use simple distillation, or we can use fractional distillation. Again, it's worthwhile to know which method to use under which situation before we go on to look at the methods in detail. So how does a separating funnel work? A separating funnel looks like this. Okay, it looks like this. All right. All we need to do is to pour the mixture into the separating funnel. Okay, so I have oil and I have water. All right. At the bottom of the separating funnel, there's actually a tap. So what happens when we open the tap is that your water will flow out into, for example, a beaker. All right. So in a very simple sense, how do we separate the mixture is that we open the tap and allow the water to flow out until the interface reaches the tap. That's when we close it. So we have effectively separated oil and water. Now, as mentioned, this is a simple description of how it works. In actual fact, if you need to separate the two, the steps are a bit more complicated. Now we'll look at the method of simple distillation. As mentioned earlier on in the video, simple distillation can be used to separate solid liquid mixtures where the solid is soluble in the liquid, and we want to collect the liquid from the mixture, so we can use simple distillation. And simple distillation can also be used to separate liquid-liquid mixtures where the two liquids can mix, so they are miscible in one another. Okay, so this part we're going to look at how we can use simple distillation to separate these two kinds of mixtures, and we'll start with the experimental setup. So how do we set up the apparatus in order to perform simple distillation? So first, the mixture is actually contained in a flask called a round bottom flask, and the flask is actually fitted with a thermometer, and it's connected via a side arm to a piece of apparatus called the condenser. And at the end of the condenser, we put a container to collect any liquid that comes out, which is we call it a conical flask. Now there are certain experimental details that we need to take note of when performing a simple distillation. The first of which is this, that the bulb of the thermometer must be placed at the side arm. Okay, it must be placed next to the side arm. Okay, this is the first thing to take note. Second thing is this, there will be water, we will actually flow water outside the condenser in the outer jacket of the condenser, and the water must go in from the bottom and come out from the top. Okay, this is the second experimental detail that we need to take note. Water flows into the condenser from the bottom, comes out from the top. The next experimental detail is this, when we heat the mixture, we actually add some small pieces of stone or sand, which we call boiling chips. So later on, after we look at how distillation works, we're going to learn why are these experimental details important. So now that we have seen the experimental setup for simple distillation, let's see how the process actually works, how the method actually works. Now we're going to use the first type of mixture first, that we have salt and water. Alright, so we have a mixture of a solid in a liquid where the solid dissolves in the liquid. We're going to see how this method works for us to collect back the water. So right now we have a salt water in the mixture. We would add some boiling chips, alright, and then we heat up the mixture. Alright, as we heat up the mixture, the temperature of the mixture will rise, and when it reaches roughly around 100 degrees Celsius, when it reaches about 100 degrees Celsius, something is going to happen. Your water is going to boil. Okay, and then your water is going to be converted into steam, which rises up the round bottom flask. Alright, after rising up, it will enter the condenser through the side arm. And what happens after it enters the condenser? Remember, the condenser has tap water flowing in the outer jacket. Alright, so the whole condenser is actually at room temperature, okay, or it's actually very cold compared to the steam. So when steam enters the condenser, it touches a cold surface, it will be converted back into a liquid, alright, and then it will flow down the condenser into your conical flask. So as you continue to heat the mixture, more and more water will be converted into steam. Alright, it will condense in the condenser and then be collected in your conical flask. So the liquid that's collected in the conical flask is given a special name. We call it a distillate. So if we were to perform the distillation for a long period of time and all your water has been distilled over, what is remaining in your round bottom flask would be your salt. Of course, it will be contaminated with your boiling chips as well. Alright, so this method is only useful for us to collect the liquid, not so much the solid. If you want the solid, we have to perform a evaporation to dryness. Now, when your water is being boiled over, so when you see liquid dripping into the conical flask as the distillate, if you were to look at the temperature, it would actually measure 100 degrees Celsius. Why? Because steam is actually entering the condenser. So steam would be at a temperature of 100 degrees Celsius. So at this point, now that we know how distillation works, let us see why are the three experimental details that we saw previously important in the method of simple distillation. So firstly, when we heat the mixture, if we do not add any boiling chips, what is going to happen is that the bottom part of the mixture will become hotter than the top part. So there's non-uniform heating. So when the mixture actually boils, it will boil very violently, which is what we don't want. Alright, so usually how do we overcome that is that we stir the mixture. Okay, and boiling chips help us to do that. So essentially your boiling chips, they are added to ensure smooth boiling. Alright, so if we ask you for the function of boiling chips, all you need to write down is to ensure smooth boiling of the mixture. How does it ensure smooth boiling? Now your boiling chips actually contains trapped air in there. So when you heat, this trapped air is being released as bubbles. Alright, and when the bubbles move through the mixture, they actually help to stir the mixture to ensure that the heat is distributed evenly. Right, so that's how boiling chips help to ensure smooth boiling. But as mentioned, if you are asked for the function of boiling chips, all you need to write down is to ensure smooth boiling. Next, we also saw that the bulb of the thermometer must be placed next to the side arm. Why? Is because when the thermometer is placed just beside the side arm, it will measure the temperature of the vapor that's entering the condenser. And how is that useful? Because the temperature would represent the boiling point or the boiling temperature of the liquid that's being collected. Okay, And once we know the boiling point of the liquid that's being collected, it will allow us to know what is the liquid that's being collected. For example, if the temperature registers 100 degrees Celsius when the liquid is being collected, it tells us that the liquid that's being collected is actually water. Okay? Next, the last experimental detail is that the tap water flowing into the condenser must flow in from the bottom and flow out from the top. In order to know why, let us look at the function of the condenser first. What is the function of the condenser? The function of the condenser, many students will say, is to condense the vapor. Now that is not enough. You have to tell us what is the meaning of condense. So the function of a condenser is to convert the vapor back to a liquid. Okay, or to convert the gas back to liquid state. That is the function of a condenser. Alright, so when the water goes in from the bottom and comes out from the top, it is moving against gravity. Right, for that it will require you to have some daily life knowledge. Imagine if you have water flowing down with gravity, chances are there will be some parts of the condenser that doesn't have any water, so it doesn't fill up the condenser completely. But when you force the tap water to move against gravity, you will find that the condenser, alright, in the condenser, your water will actually fill up. Your tap water will actually fill up the condenser completely. Alright. So when the entire condenser is filled up with water, then your cooling will be effective, more effective. Alright, and we ensure that all the vapor is condensed back to a liquid, and then we collect them in the distillate. Next, we'll look at the separation of two miscible liquids. An example would be ethanol plus water. Okay, so same thing, we put the mixture in a round bottom flask and then we heat up the mixture. Now what is going to happen is this: ethanol has a boiling point of 78 degrees Celsius and water has a boiling point of 100 degrees Celsius. So when we heat up the mixture, the temperature of the mixture will rise until it reaches about 78 degrees Celsius. Then what is going to happen? Your ethanol is going to boil. Alright, so your ethanol is going to be converted into vapor form, whereas at 78 degrees Celsius, water is not supposed to boil yet, so it will remain as liquid. So what happens is that your ethanol vapor will rise up and then it will enter the condenser through the side arm. In the condenser, your ethanol vapor is going to be converted back to liquid, and then it's going to flow into your conical flask and be collected as the distillate. So if you were to continue to heat the mixture, what is going to happen is that more and more of your ethanol will be boiled away, and the remaining mixture will be more and more of water remaining. There will come a point where all your ethanol would have been completely boiled over, and then what happens is that the temperature of your mixture now, or the temperature of the liquid remaining in the round bottom flask, will continue to increase. Alright, so during this period that you will not see any liquid coming out as distillate. Alright, so that tells you that all your ethanol has been completely distilled over, and it's time to change a container, or it's time to change a conical flask. So the temperature of the liquid in the round bottom flask will continue to increase until it reaches about 100 degrees Celsius. That's when the next liquid, your water, will be converted into steam and then will be collected as the second liquid. So in simple distillation, or in distillation in general, an important concept is that the first liquid to be collected is the one with the lowest boiling point. Okay, the lower the boiling point, the earlier will the liquid be collected. Now, whatever that we have seen for distillation now is a simplified picture of what is actually happening. Okay, so next I will show you what really happens when you heat the mixture of ethanol and water. Now, as mentioned, the temperature will rise to about 78 degrees Celsius, and then that's when your ethanol will start to boil. So your ethanol vapor will rise up to the side arm. Now, question is this: will the gas contain only ethanol? Answer is no. Why? Because it will have a little bit of water as well. Right? But water is not supposed to boil at 78 degrees Celsius. Correct, but can water evaporate at 78 degrees Celsius? Answer is yes. Evaporation can occur at any temperature. So the gas that rises up would contain a bit of water as well. Alright, so some of this water is going to enter the condenser as well and be collected in the distillate. So if you perform a simple distillation, the ethanol that you get is not 100% pure. Maybe it is 95% pure. Alright, why? Because some of your water can actually evaporate at 78 degrees Celsius, and then it also enters the condenser and is being collected together with the ethanol. So the distillate contains a little bit of water, which makes your ethanol not 100% pure. Alright, so having said that, simple distillation will not produce very pure distillate. So we'll only recommend simple distillation for separating two liquids if the difference in their boiling point is more than or equals to 30 degrees Celsius. Alright, so they have very, very different boiling points. Then we use simple distillation to separate two liquids. However, if you look at ethanol and water, the boiling points are less than 30. So actually, if you use simple distillation, the distillate that you get will not be very pure. In order for us to get pure ethanol or ethanol of higher purity, we need to perform a different method. We need to use a different method called fractional distillation. So this is the experimental setup for fractional distillation. It looks very similar to simple distillation, just that we have one additional piece of apparatus. What is this apparatus called? It's called a fractionating column. Okay, in a fractionating column, it contains a lot of glass beads. We will see what the glass beads are for in a while. Okay, so back to heating a mixture of ethanol and water. So once again, ethanol has a boiling point of 78 degrees Celsius, water has a boiling point of 100 degrees Celsius. So when we heat the mixture, temperature of the mixture is going to rise until it reaches at about 78 degrees Celsius. Then your ethanol is going to start boiling and be converted into gaseous state. Okay, at this point, however, remember there may be some water vapor as well, because water can also evaporate at 78 degrees Celsius. So now, instead of the gas or the vapors entering the side arm, entering the condenser directly, it will pass through the fractionating column. Alright, so what the fractionating column does is this: when the vapor reaches the fractionating column, alright, there are many glass beads there that provides a surface for any vapor that's not supposed to be boiling, alright, that has not reached the boiling point yet, to condense on. Alright, meaning at 78 degrees Celsius, is water supposed to boil? Answer is no. Alright, so when water touches the glass beads, they will condense and fall back into the mixture. At 78 degrees Celsius, is ethanol supposed to boil? Answer is yes. So ethanol vapor would travel through the glass beads and enter the condenser. Same thing, after entering the condenser, it's converted back into liquid state, and then it's collected as the distillate. Alright, so what the fractionating column does is to trap the vapor that's not supposed to be boiling at the temperature yet. Okay, so how do we write that in words? Fractionating column provides a large surface area for vapor to condense. And what's the purpose of the fractionating column? To provide better separation of the vapors. Okay, so if you have a mixture of two gases entering the fractionating column, the fractionating column will actually trap the vapor. It will cause the vapor that's not supposed to be boiling yet to condense and fall back into the mixture. Whereas the vapor at the boiling point, the vapor which is at the boiling point, will continue to rise up the fractionating column and enter the condenser. So with that in mind, we can see that fractional distillation is more effective at separating two miscible liquids. So it's generally recommended when you have two or more liquids that are mixed together to use fractional distillation. However, there's also a limitation. Okay, even with the fractionating column, if your boiling points of the liquids are very close, for example, if your boiling points are less than 5 degrees Celsius, okay, then we will, even with a fractionating column, we will not be able to achieve a good separation, meaning the distillate that we get will not be very pure. Alright, so for fractional distillation to work, the boiling points must at least be 5 degrees apart. Okay, meaning, for example, if I have something that has a boiling point of 98 degrees Celsius, liquid A, and liquid B which has a boiling point of 100 degrees Celsius, even with fractional distillation, we will not be able to achieve a clean separation of liquids A and B.